All right, today we're going to talk about measuring and constructing angles. Okay, yesterday we talked about measuring and constructing segments. Today is measuring and constructing angles. Very similar. Okay, very similar to what we did yesterday. Measuring and constructing angles today, section 1.3. If you have your Blackboard accounts, you can pull up your notes on Blackboard if you like it. Some people have them already. Measuring and constructing angles, section 1.3. First thing we're going to talk about is an angle. An angle is a figure formed by two rays with a common endpoint. Okay? An angle could look something like that. There's an angle. There's an angle. Is that an angle? It would be a straight angle. So 180 degrees. Correct. That is technically an angle. Vertex. Vertex is the common endpoint of the sides of the angle. Vertex. Whenever I think of vertex, you got to think of kind of the letter V. Why? Because it makes an angle. A vertex is the point of the angle. So it is the tip of the angle. It's where the two sides meet. That is the vertex. Interior of an angle. What does interior mean, Callie?
A set of all points between the sides of an angle.
What does the word interior mean, though?
Inside.
So interior of an angle means the inside of an angle. So if I have an angle here, the interior of that angle is anything on the inside. Anything between the angles. That is the interior. Exterior of an angle. What does exterior mean, Trent?
The outside.
Yeah, so same thing here. If I have an angle, exterior means now a point on the outside of the angle. So any point on the outside. Measure. Angles are measured in degrees. An angle is a 1/360th of a complete circle. Does anybody guess why it is 3/60th? Because that's a circle. If I were to go all the way around, that gets me 360. So an angle is 1/360th of the complete full circle. Okay? So angle, we're talking a lot about angles today. We'll talk about some vertexes, interior, exterior, and measures. Next, we have the types of angles we have. Okay, degree is a unit of angle measure. 1 degree is just like measure. Next, we're going to talk about an acute angle. If you look up on the board up there right in front of Ty, up on the posters, there's a poster of an acute angle. An acute angle are the small angles. So they are the angles that are less than 90 degrees. Okay, those are the angles that are less than 90 degrees. A right angle is an angle that measures exactly 90 degrees. What typically goes at the vertex of a right angle? A little square goes right in the vertex there. If you see a square in the vertex there, that denotes that it is a right angle. Obtuse angle. Obtuse angle is the large angles. So obtuse angles are the large angles. They are the angles that are larger than 90. And then we have a straight angle, as Brock said. Straight angle is nothing more than a straight line. So that's 180 degrees. That's a straight line. What's the word congruent mean, Jake? So, no, just the word congruent. What's the word congruent mean? Same. Yesterday we talked about the congruent segments. Congruent segments have the same what? Same congruent segments, same length. So what do congruent angles have, you suppose? Like the same angle? The same measure of the angle, right? Yep. So congruent angles have the same measure. And then an angle bisector. We talked yesterday. What does bisect mean? Anderson, what does the word bisect mean? Cut in half. So an angle bisector, what do you suppose that does to an angle? Cuts the angle in half. Let's say I have a 90-degree angle. And I put an angle bisector in there. If I have a 90-degree angle and put an angle bisector in there, what are the two smaller angles now going to be? 45. There would both be 45 because that is an angle bisector. Cuts the angle in half. Okay, first thing we're going to talk about here today is identifying angles. Again, angle is a figure made up of two rays or sides that have a common endpoint called the vertex. Vertex is the point there. There's a lot of different ways to name angles. If there's no other angles, you could say it's angle Y. So it's the angle at that vertex. So if there's no other angles up there, it's just the one, you can say, hey, that's angle Y. You can use the vertex. I prefer it if you use this right here, the three-letter system. When you use the three-letter system, the key is that the vertex must be in the middle. So angle XYZ or angle ZYX. Notice both times I said that the vertex was in the middle. Could I have said angle YXZ? Would that be all right? No. Why? Because my vertex is not in the middle. The vertex, your point, has to be in the middle. And then sometimes they give you numbers, and if they give you numbers, you can just say angle that number. So for example, angle 2 there. So let's look at number 1. I want to name each angle in 3 different ways. Chris Ekstrom, give me one way to say that angle.
Angle PQR.
Angle PQR is a great way to label that. Colton, what's another way to say that angle? Angle RQP. What's a third way to say that angle, Blake? Angle Q. And this one actually has a fourth way. What's a fourth way I could say this angle? Yes, sir. You? Yeah? Angle 1. Yeah. If I have a number there, I can just say angle 1. Number 2. What's another, or what are 3 ways I could label number 2? Becca, give me one way. I could say angle J. What else could I say, Parker? What's another way I could say this angle? Angle HJK. And what's the third way, Quinn? Angle KJH. That'd work. Could I give it an angle the number here? Can I say angle number something? No, why not? Because there's no number. So that one won't work. Number 3, name the 3 different angles. There are 3 different angles in there. Does everybody see all 3 angles? There's 3 different ones. Katie, give me one of the angles.
ABD.
I can say angle ABD. That's an angle. That'd be that angle right there. What's another angle, Callie?
ABC.
Angle ABC. That is the larger angle. So that's the big angle there. And lastly, what would be the last angle that I would use? Jeremiah? Angle what?
DBC.
Angle DBC. Good work, sir. All right. So that's the way to label angles. Next, we're going to classify some angles here. So we already talked about it. We have acute, right, obtuse, and straight angles. Okay. So I have the different types of angles there. Acute is 0 to 90. Right is 90 degrees. Obtuse is 90 to 180. And straight is 180 degrees. So if I want to look at angle NMP, I want to identify angle NMP. How would you classify angle NMP? Luis, what would you say? That would be obtuse. Good work, sir. Next, I want to do angle QMN. Maxie, what about angle QMN? That is a right angle. And last, I want to say angle PMQ. Hannah, what about angle PMQ? Can Audrey see it? What? That'd be an acute angle. Good work. That's an acute angle. Sometimes we also have to classify angles with a protractor. Does anybody know what a protractor is? They're used to measure angles. It asks us to find and classify angle XWZ. So I have angle XWZ here. Well, if you look at it here, well, how would you classify that, Caden? What type of angle would you say that is? Oh, XWZ. That'd be obtuse. Now, how would I find the exact measure of that angle? Who thinks they know how to find the exact measure of that angle? What would you have to do? Brock, you said 120 degrees. How'd you find that?
So it's 160 minus.
Yeah, 160 minus 40. You take the measures on the outside, right? Could I have done 140 minus 20? Could I have taken the measures on the inside? Does that still give me 120? Okay. Could I have done 160 minus 140? Would that work to find me that angle? No, yeah, I can't do the outside and the inside. Okay, if you're doing the outside, you have to make sure you follow all the way along and use the outside on the other side as well. Okay, if you're using the outside, use the outside. If you're using the inside, use the inside. All right, number 8 says, find and classify angle YWZ. So here's YWZ. Reed, what do you suppose that angle is? That is a right angle. How many degrees is a right angle, Reed?
90.
That is 90 degrees. Nice job. Try these two. Same idea. Find and classify the following angles. Take a couple seconds to try these two. All right, Simeon. Number 9 says angle BAE. What type of angle is that, Simeon? That is obtuse. And what is the measure of that obtuse angle, Simeon? 100 how much? 115 degrees. Nice job. Number 10 says angle DAE. Angle DAE. What type of angle is that? Parker. That is acute. What's the measure of that acute angle, Parker? This one is 110, and that one is at 135. So that'd be 25 degrees. Good work, sir. Okay, last thing we do, we can find angles. Okay, just like we're talking about with measures, like we did yesterday with segments. If I had two angles, for example here, if I say that XVW is 48 degrees and WVU is 48 degrees, how could I find the big angle here? What do you suppose I would do? I would add them. I'd take 48 plus 48, and the big angle is now 96. Same thing in reverse. What if I give you a big angle here? What if I say this angle is 90 degrees? So let's say this angle here is 90 degrees. And I cut it up here, and now this angle is 50 degrees. Well, how would I find the blue angle there? You subtract. 90 minus 50, the other angle now is 40. Ooh. Yeah, that'd be 40 degrees. So it's just like yesterday with segments. You can either add them to get the whole angle or subtract them to get the part angle. Okay? So number 9 here. I want to find the measure of angle CFB. So I'm going to label this here. CFB. If AFC is a straight angle. What's it mean to be a straight angle, Caden? Yeah, what's that straight angle? How many degrees would a straight angle be? Or 180. So straight angle is 180. So if the straight angle is 180 there, so that red angle up there is 180, how can I find the one that's highlighted? How would I be able to find that angle? Beast, what do you say?
180 minus 78.
Yeah, we do 180 minus 78. And the other angle has to be what then, Beast? Yeah, that has to be 102 degrees. Okay, good work. So I know that this angle now is 102 degrees. Next one. It says measure of angle EFA. So I want to find the measure of angle EFA if the angle is congruent to DFE. So if the highlighted one is congruent to the one in red, what's the highlighted angle have to be, Ty? If the highlighted angle is the same as the angle in red, what's the highlighted angle have to be? It'd have to be 51, right? I agree with you. Because what does congruent mean? It means they are the same. Good work, sir. So that one is now 51 as well. So this one's 51. Okay, I want to find the measure of angle EFC. So I want to find the measure of angle EFC if DFC and AFB are congruent. This right here, this symbol, that is the congruency symbol, in case you're wondering. That is a congruency symbol. It has an equal sign with a squiggle above it. That is a congruency symbol. It means they're the same. Okay, so if DFC is the same as AFB, well, Blake, what's DFC have to be then? Okay, this angle has to be 78. Well, then how would I find that highlighted angle, Blake? I would say 51 plus 78, and I'd get what, Blake? 129 degrees. Good work, sir. So this one was what? 51, and that one was 78. Last question. It says measure of angle CFG if FG is an angle bisector of CFB. Now what's wrong with that one? There's no G, but what's it say FG is? FG is a what?
Bisector of CFG.
So I'm going to draw in FG. I'm drawing in FG. Okay, so there's G right there. And it's an angle bisector. What's it mean to be an angle bisector again? Cuts in half. Remember what CFB was? What was CFB? CFB was 102. So if it cuts in half, what are the two angles going to be now? 51 degrees. Okay, so just like that, we can find all of the missing angles in a problem there. Okay, just kind of go around taking it step by step. Using the same idea with some easier problems now, try to find the missing angles in these two. Notice the diagram is not to scale. Please recognize that. Use the diagram. It is not to scale to solve the following problems. Okay, you're just using the diagram kind of so you can visualize where these points are. But take a couple seconds to try these two on your own. All right, moment of truth here. Let's see. First one says ABD is 37 degrees. So ABD is 37. ABC is 84. And I want to find DBC. So what would the answer be there, Clark? Nice job. How'd you find that, sir?
You take 84 minus 37.
Good work, sir. That is correct. Next one. It says the measure of angle ABC is 115. So the big angle is 115. ABD is 48. How would I find the measure of angle DBC? Beast, what do you say?
67.
How'd you find that, sir?
115 minus 48.
115 minus 48. That is correct. Okay, so again, you can add or subtract to find missing angles. Last part today. It says BD bisects angle ABC. What's it mean to bisect, Anderson? Cuts in half. So what does that mean about these two angles down here? Those two angles would be the same. They're going to be equal. So it says ABD is 6x plus 3. It says DBC is 8x minus 7. How would I solve for x here now? What would I have to do, Claire? What do we know about the two angles? They're bisectors, right? So the two angles are what? They're equal. So what do I do with the two expressions? Set them. Repeat what you just said. Yeah, set them equal to each other. So I would say 6x plus 3 equals 8x minus 7. Why do I know that they have to be equal? Because they are what? Because they bisects it. Bisects it means it cuts it in half. So I can solve for x now. I'd subtract 6x over. Add the 7 over. 10 equals 2x. X comes out to equal what, Katie? Is that my answer, Katie? No. It wants me to find a measure of angle ABD. So I would take that 5, plug it in for ABD. And I get an answer of what, Katie? 33 degrees. Take a couple seconds, try number 16 on your own now. Same idea. All right, so number 16 here. I know that ABD is 4x plus 6. CBD is 7x minus 12. What do I do with those two expressions, Trent? I combine them?
Make an equation.
I make an equation by setting them what?
4x plus 6 equals 7x minus 12.
Yeah, 4x plus 6 equals 7x minus 12. And now I solve. When I solve, I get x equals what, Jeremiah?
X equals 3. Right, not x equals 3x. Look. X equals 6.
I get x equals 6. Is that my answer?
No.
Nope. So I have to plug it in. I want to find ABD. So I plug it in up there. And what's the angle come out to be, Jeremiah?
30.
30 degrees. Good work. There's your assignment.